Welcome back. This is our last section on study design. And study design is the process of planning, conducting, and drawing conclusions from a statistical study. In this specific lesson, we'll cover experimental design and inference. We'll learn the principles of designing a valid experiment, including treatments, control groups, random assignment, and ways to reduce bias. We'll also discuss how well-designed experiments allow researchers to make valid cause and effect conclusions and recognize the limits of those conclusions. So we're going to go over some vocabulary. Some of this is review from previous sections on sampling. We're going to go over both the sampling and experiment vocabulary for our first section of this lesson on experiment designs. So we've already covered these definitions of sampling in the last video on sampling. So we have a cluster design, stratified sampling, and systematic sampling. So cluster sampling is when entire groups get selected together, and then we test every member of that group. Stratified sampling is we group things first, and then we take samples of these. And again, these are not experiments; these are just sampling methods. And then we have systematic sampling, which is we just pick a random starting point, and then every nth value or for example, every 10th or 100th member of the study gets selected. But we're going to focus primarily on experiments. We might need some of this sampling vocabulary for later. But sampling is basically asking the question, who do we include? Who are we including in the study? Um, and experimental designs happen after the study begins because they determine how treatments are assigned to the participants. So it's sort of like now that we have these people selected, what are we going to do with the participants? And there's different ways that we can design experiments. The first one is a completely randomized design. And this is where subjects are assigned just at complete random. So we randomly split everyone. We also have randomized block design, which is where we make groups first based on different characteristics, and then we randomize. We'll randomly assign treatments within each of those groups. And then finally, we have matched pairs design. And this is where we make pairs instead of groups. So we might have two similar people, or just one person gets both treatments. Um, one treatment is randomly assigned within each pair. That's one way that you can do a matched pair. Uh, we'll look at some examples or an example of matched pairs, and I think that will probably make a little more sense when we go over some examples. But make sure you have these in your notes. Take a screenshot or write them down in your notes, or both. That would be great. Also, these are some common experimental terms that we need to know as well. These are just basic terms that we're going to see within the word problems. Treatment is what the subjects receive. The explanatory variable is what is changed or compared. The response variable is what is being measured. The control group is the comparison group. It's the group that doesn't change at all. It's just the baseline group. The placebo is a fake treatment. The random assignment is where we randomly assign treatments. A single blind study means the subjects don't know certain things. A double blind study means the subjects and researchers don't know certain things. And then finally, we have the confounding variable, which we're going to see in the end of this lesson in particular. And this is just something that affects the results. And this can make us get results that are inaccurate because of some extra variable. We call that the confounding variable. So again, make sure you have a screenshot of this, or you can write down these notes here. If you can write them down, that's great. Okay, so we're going to go over example number 1. And this is asking us what type of experiment design is this? So we're going to read through this and try to figure that out. It says an insurance company wants to study whether offering incentives for preventative care reduces overall health costs. So the insurance company is basically asking uh, people to do things ahead of time medically, so that way they don't incur more medical costs. That's what that opening statement means. So they randomly select a sample of 200 of their customers. And the company ranks the customers according to total healthcare costs for the previous year. For every 2 customers in order from the list, the insurance company randomly assigns 1 customer to be offered the incentive and the other to the control group. And it says, what type of experiment design is this? Okay. So I'm going to give a sort of a cheat sheet to look at here for these. So a completely randomized study means that they randomize everybody. It looks like since the subjects were first put into pairs with another similar customer before being randomly assigned, the study didn't use a completely randomized design. So it's not going to be A. Cross out A. B says a cluster sample with randomizing groups. This is this is a sampling method. So this is not an experiment design. Cluster sampling is a sampling method. So is stratified sampling. It's a sampling method. It's not an experiment design. Randomized block is where we have a group and then we randomize that. This one's not randomized blocks. Um, there is a more appropriate name for this. When the blocks are small, like 1 or 2 subjects, we don't call it randomized block. This is matched pairs. So the subjects were first put into pairs with another similar customer, and it was randomly determined which member of each pair was offered the incentive and which one wasn't. So this is matched pairs. So they're put into pairs. It says for every 2 customers, they randomly assign them. So they pair it and then they randomize. So if this cheat sheet helps you a little bit more, you can use that for these uh, first first types of problems. Let's look at one more of these. Another insurance company problem offering incentives for preventative care, and they're going to select a random sample of 200 of their customers. Um, these are people who are smokers, so half the smokers are randomly assigned to be offered the incentive, and the other half are assigned to the control group. The same method is used to randomly assign half the non-smokers to the treatment group and half to the control group. What type of experiment is this? So in this case, I'm not going to go through all the counter examples because I think that's going to take a lot of time. In this case, this is going to be a randomized block. And the reason is that the subjects were divided into groups based on their smoking habits before they were randomly assigned. So we determined beforehand, are they a smoker or are they a non-smoker? And so they use a randomized block. Um, the reason it's not matched pairs, because you might think, well, maybe it's matched pairs because there's 2 things going on here. Uh, each subject didn't receive the incentive and the control, so this isn't matched pairs. So they were divided into groups based on their smoking habits before being randomly assigned. So this is randomized block. And again, having your notes out for these is going to help you immensely. We're going to go to the next section now on experimental design considerations. In um, this next section will cover important considerations in experimental design. So we'll learn the purpose of control groups, randomization, and different experimental designs, as well as how to recognize common mistakes and misconceptions about experiments. We'll be applying our same sampling and experiment definitions for these problems as well. So if you don't get a chance to copy these definitions from earlier, if you didn't get a chance, excuse me, uh, here's a shorter version of how they're defined. So cluster sampling, randomized groups, stratified sampling, we have a group and then we sample some from the groups. Systematic sampling, we randomly start somewhere and we choose every nth person. For experiments, we have completely randomized, which is we randomize everybody. Randomized block, we have a group, we pick groups, and we randomize, and then matched pairs is we have pairs and then we randomize. So that's kind of a shortened uh, method for determining sampling methods and experimental methods. Okay, we're going to look at some more examples, and I put those notes here as well as the common experimental terms here next to our first example here, because I think we're going to need some of these experimental terms for this problem. So a company makes a bracelet and has magnets, and they claim that it improves balance and overall athletic performance by wearing the bracelet. Researchers recruit volunteers for an experiment, and the subjects will test the effectiveness of the bracelet by performing a variety of athletic challenges with and without the bracelet. So each subject will do each challenge 3 times. They're going to wear the bracelet. They're going to wear the placebo bracelet, which I believe they're probably going to think that it is the real bracelet, but it's the placebo bracelet. That's what the word placebo is. It's the fake treatment. And then they're not going to wear a bracelet at all. And so the order is going to be randomized for every activity. And the subjects don't know which bracelet is the real magnetic bracelet and which one is the non-magnetic bracelet. And the question says, why did the researchers include the scenario where subjects wear no bracelet at all? Well, the no bracelet at all, this is our control group. Let me highlight that. If they're not going to wear a bracelet at all, that means that uh, they want to know what's happening uh, when nobody is wearing a bracelet. Are they able to? What's their baseline performance? I guess that's probably the best way to describe the control group in this case. And so when they're not wearing a bracelet at all, that serves as our control group to compare the baseline. Um, so that would be the answer for this one. Looking at the randomized block design, random cluster design, um, each group in the study is a treatment or a control group. So no blocking was used in this study. Random cluster design is a sampling method. It's not experimental design. Um, And then C says to correct for using volunteers rather than a random sample. Adding groups to a study doesn't correct for this concern where they're doing no bracelet at all. And then D says non-response is a concern with surveys, but it's not much of a concern in an experiment with volunteers. So to control against non-response, um, they're still responding, so it's not D. So I'm just going to cross out all these. So that's what our control group is. Okay, going on to the next example. We have all of our definitions here for this next one too. So again, a company makes a bracelet. This time this bracelet is designed to repel mosquitoes so that people don't have to wear bug spray. The researchers at the company are designing an experiment where volunteers will be assigned either the bracelet or the bug spray to use in their homes. And the researchers want to use a randomized block design. So the randomized block design means we're going to group participants and then randomize them. How should the researchers form the blocks is our question. So we're going to go through these different answer choices here. So answer choice A says both the volunteers and researchers should be kept blind as to which block the volunteers are in. So if both the researchers and the volunteers are blind, this is called a double blind study, not blocking. So A is double blind. I'm just going to write that in here, just so we can see some counter examples for some of these example problems. There's a lot to read through, so I'm not always going to explain all the counter examples in great detail, but just so you know, that's double blind. So B says, how should they form the blocks? Volunteers within each block should live in similar environments to each other when it comes to mosquitoes. This is what blocking is for. We group similar subjects together first. So B is correct because a randomized block design groups subjects who are similar in an important way before randomly assigning treatments. Since mosquito environment can affect the response variable, the volunteers within each block should live in similar mosquito environments. So B is our correct answer for how they should form these blocks. Let's look at C, D, and E. C says volunteers in one block should use the bracelet while volunteers in the other should use bug spray. I think that's really close, but this is kind of the trap here. If one entire block gets one treatment, then we've confounded the treatment with the environment. So you couldn't tell whether the differences were caused by the bracelet or by the mosquito conditions. So instead, each block should contain both treatments. So not C. For D, it says volunteers within each block should live in different environments from each other when it comes to mosquitoes. This is the opposite of blocking. Uh, they should be in the same environment because we want to be able to compare the effectiveness of bug spray or the bracelet uh, based on the same environment. So D is not correct. And E says each volunteer should be randomly assigned to a block. So E is not correct because the blocks should be based on an important characteristic, not just randomly created. And in this case, our blocks are based on the mosquito environment. Okay. All right. So the key idea here is when you're putting people into blocks, we want, or anything into blocks, we want the important characteristic to be as similar as possible within each block. Okay, so make sure you have the common experimental terms written down as well, because you're going to need to know all of these for study design also. Okay, on to the next part on conclusions in observational studies versus experiments. When we're making conclusions about studies or an experiment, we have to ask ourselves, is there an association or is there causation? Uh, and we're going to be able to determine when cause and effect conclusions are appropriate, and also continue applying these study definitions that we've already learned to solve these problems. So some very quick vocabulary to go over is association means that the variables are related. We have positive and negative associations, where positive association means that as one variable goes up, the other one goes up. So positive association means that as one goes up, so does the other. And we have a negative association, which means that as one variable goes up, the other one goes down. And then no association means that there's no clear relationship between the variables. And we saw that earlier when we were looking at scatter plots. Like no association would be like just like random dots. We don't know if there's a positive or a negative association. Okay. I think we use the word correlation, positive or negative correlation. Okay, and causation means that one variable actually causes the other. So association, again, that means that they're related, but we don't know if there's an actual cause or not. We're going to look at some examples. I think this will make more sense as we go through. This first example says that they did a study of players playing this video game. And they said that people tend to perform better if they take breaks. And the study involved analyzing data from 242,000 matches played by 16,665 players of League of Legends, which is a popular online game. And the data showed that players who took regular breaks performed better than those who did not. And we want to know, what conclusion can we draw from this study? Okay, so I think reading back on this, the key idea is that the researchers did not tell the players to take the breaks. The researchers observed that players naturally took breaks and they compared the results. So this is an observational study. That's the first thing that I noticed from this. So this is an observational study. That means that it's either an observational study or an experiment. So because it's not an experiment, we're going to cross out any of the answer choices that say experiment or imply experiment, if there are any. And I don't think that there are in this example. But because it's an observational study, um, that means that there could be other explanations. So there could be other explanations of why people who took breaks did better. One example might be that players might naturally take more breaks, that people who are better might naturally take more breaks. Older players might take more breaks, which means they also might be better, and so they might take more breaks. More experienced players might take more breaks. Players with more free time might take more breaks. The study can't separate all these possibilities from the effect of taking breaks. So there can be many reasons people are taking breaks. Um, so for that reason, we can't say there's causation. This is observational. And so this is an association. So this one is E. Observational studies show associations. Okay, let's go to the next one here. This one says Jillian has been updating the design of a media streaming website, and she wonders if users will spend more time on the site with the new updated website design. So she designs a study. She starts with a random sample of 1,000 users and randomly assigns half of them to the old design, and then half of the other half to the new design. And after a week, she notices that users with the new design spend significantly longer on the site than the users with the old design. So the question is asking us, can we conclude that the new design caused users to spend more time on the site? Why or why not? So first of all, let's identify, is this an experiment or is this an observational study? This is an experiment. So she is placing these people into groups. This is an experiment. Okay. So looking at this now, it says yes, because the sample size was large. Well, we don't use sample size. I'm looking at answer choice A here. We don't use sample size to determine whether or not we can make a causal conclusion. So A is not correct. B says yes, because users were randomly assigned to treatment and control groups. So the treatment group here would be the new website, and the control group would be the old website. And so we can say, yes, this is an experiment that caused um, people to spend more time on the site. She noticed that users with the new design, they spent much longer on the site than users with the old design. So we can say that this is causation for this. Um, Looking at sample size being too small, a general rule of thumb is sample size should be 30 or more. That's just a general rule of thumb for statistics. I don't think we're going to get many questions with the sample size on here. E says this wasn't an experiment. This was an experiment. Probably should have crossed that out first. And then um, the users being randomly selected, that has nothing to do with causation. So kind of a quick summary, if it's an observational study, it's an association. If it is an experiment, we can conclude causation. Let's look at one more of these. A superintendent of a large school district is curious about the relationship between students' grades and their participation in extracurricular activities. They take a random sample of 500 students and find that the students with more participation in extracurricular activities are far more likely to have high grades than students with little or no participation. What conclusions can we draw from this study? Okay, so we need to determine, is this an observational study or is this an experiment? So it says that he took a random sample of 500 students and found that those students um, with more participation are in extracurricular activities and have higher grades. So he just took a random sample of 500 students. He didn't have a control group. So this is an observational study. I'm just going to put no control group. Okay. So because it's observational study, we can say that there is an association. And that one is answer choice C. I think that's the only one there that says that there's an association. So the key idea again is observational studies just observe existing behavior, and experiments, they assign treatments to subjects and oftentimes have a control group. Okay. All right, the next section is we're going to look at finding errors in our conclusions. I believe this is the last section of this lesson here. So here we're going to use what we've learned about already about causation and association. We're also going to think about our key terms like let me see some. Let me put these key terms up here just one more time so that we have them because I think that that's going to be helpful for us to have all of this here. Just copy this to here for you so you can see that. Okay, because we're going to need these experimental terms for all of these. But this first one wants us to find errors in study conclusions. So it says that Jerry was reading about a study that looked at the connection between smartphone usage and happiness based on the data from approximately 5,000 randomly selected teenagers. The study found that on average, the teens who spent more time on smartphones were significantly less happy than those who spent less time on smartphones. Jerry concluded that spending more time on smartphones makes teens less happy. Was his conclusion, or excuse me, why is Jerry's conclusion not appropriate? Okay, so we have all our definitions here. Our first step is we're going to identify if this is an observational study or an experiment. Okay, so it looks like this study doesn't impose a treatment, and it observed smartphone usage and happiness. So this is an observational study. And I think we might not need the experiment design for this one, so I'm just going to delete that. I'm just going to write observational study. for step one. We're just going to determine the type of study. Step two, we're going to rule out the answer choices that are the opposite of. So we'll see if there's any answer choices on here that show experiment. A says the study was an experiment. So we're going to cross out A because it was observational study. C also says the study was an experiment. So we can cross that one out. Okay, now let's go through the rest of these. For B, it says the study was observational, so he shouldn't make um a causal conclusion. So because it's observational, he shouldn't have said that there's causation. And this says why is his conclusion not appropriate or not correct? Um, B is why it's not correct. An observational study means association. Okay. Um, D says the study was observational, so the sample size isn't large enough. The sample size certainly is large enough, so that doesn't have to do with observational or not. The sample size, it says, was 5,000 students. That's quite a bit of people to sample. Uh, and then it says the study wasn't a census, which is the best way to establish causation. Census means that everybody did one thing. So that's not true either. We don't have to have census for there to be causation. Okay. All right. Looks like we have two more examples to go. So the next one is saying that researchers recruited participants for a wine tasting study that included a variety of wines in terms of style and price. Participants tasted a series of wines in random order, and the participants they could look at the bottle for each wine, and they could also see its price and label information as they were tasting and rating the wine. And the study found that the participants rated the more expensive wines significantly better tasting than the less expensive wines. The researchers carrying out the study conclude that the more expensive wines tasted better. So the people that were drinking these wines, they said that the more expensive ones were better. And so the researchers just said, okay, that must mean that the more expensive ones taste better. But it says, what's the confounding variable that makes the conclusion inappropriate? And again, the confounding variable is another variable that affects the accuracy of our results. So because the participants knew the price of the wine, they, in the back of their minds, most likely they were thinking, well, this is a higher priced wine, therefore it tastes better. And really, they should not have been given that information. That's considered a confounding variable. So the lack of blinding in the study, the participants should have been blinded. They should not have known whether they were drinking expensive or inexpensive wine. Okay, and our last example. Uh, Ricardo suspects that his cat will prefer new cat food to their current cat food. The next time that he feeds his cat, he decides to feed him in a different room than normal. He puts a bowl of the new food on one side of the room and a bowl of the normal cat food that the cat's been eating all along on the other side of the room. And he determines what side of the room that he's going to put the food on by flipping a coin. So it's totally random. And his cat chooses the new food. Ricardo concludes that his cat prefers the new food to the current food. So this says, what makes Ricardo's conclusion inappropriate? Let's think about it for a second. He did randomize what side of the room he'd put the food bowl on, but the cat might prefer one side of the room or the other side of the room. Maybe there's like a large window in one room. The cat likes being by the window, or maybe it's really warm in one part of the room and the cat doesn't want to be warm. There's many different reasons for this where randomizing just might not be enough. Um, the random assignment of the bowl placement, um, he still did it randomly, so that's not correct. Um, the exclusion of other cat foods, no, he was just testing the original and the new, so C doesn't have anything to do with it. The use of only his cats and not other cats, well, he wants to know if his cat prefers the new food, so that's not true. And the lack of attention to the placebo effect, there's no placebo effect in this example. So A is the correct answer. The lack of replication. So he only did this one time. If he really wanted to know that his cat prefers the new food, he would continue to do the experiment. Maybe every day when he feeds his cat, he'd flip a coin, decide which side of the room to put it on, and then continue to do that, and then could get more accurate results. All right. So this has been a lot of reading problems and vocabulary terms in this unit. This last section, this is our last section on study design. So if you need to go back and review some of the other topics from this unit, definitely be sure to do that so you can write down all the key terms. Again, when you're reading through these problems, try to decide or try to ask yourself, who is the population and the sample? So who is being studied and who is actually selected? So this is all of, oops, clicked my pen on accident. This is all of this unit. So this lesson and the last two lessons. Who is the population and sample? Who's being studied? And then who is actually selected? That's number one. Number two, how were the subjects being selected? So was there a sampling method? What was the sampling method? And was there any bias at all? The third question you should ask yourself, and this is for many of these questions, almost all of these questions, is this an observational study or is it an experiment? Did the researchers only observe or did they assign treatments? And then four says if it's an experiment, what experimental design is being used? So the experimental designs we went over was completely randomized, randomized block, or matched pairs. And then five is what conclusions can be made from the study. So is this an association or a causation? And then finally, we need to ask ourselves, is the conclusion appropriate? So again, this is what we should be asking ourselves whenever we're considering study design questions. Okay, so that is everything for this section on experimental design and experiments, as well as that summary on all of this unit on study design.